Hello, 20-1s. Real short little lesson here, but an important piece of information about restrictions on variables. As the math becomes more complex and we start to go to unique situations, well, and we've already started to look with some of the problem solving, not all answers are acceptable. Well, that's what we have to be careful of. If we started to work with radicals and variables, well, not all variables will work. But why? We have to identify what variable values don't work in certain situations. And that's what a restriction is. It's telling us, hey, here's an answer, but consider the fact that. And that's what we want to take a look at. Well, what we have to be aware of, actually, let's go back to this for a second, with square roots, since that's what we're mostly focused on. When do we run into problem with a radicand and a square root sign? What situation will we get that I'm really hoping you're going to look at and say, can't do that? Well, that's when we have a negative under the square root. We can't, well, can we square root 25? Absolutely, that's 5. Why? Because 5 times 5 is 25. But can we square root negative 25? We can't, because there is nothing times itself, because positive times a negative is what gives a negative value. So negative 25 can't be rooted. So we have to put restrictions so that we avoid square rooting a negative. What's nice with cube rooting is anything goes. Because with cube rooting, can we cube root 27? Sure, 3. Because 3 times 3 times 3 is 27, not a problem. Can we cube root negative 27? We can now, because a negative 3 times a negative 3 times a negative 3, will equal negative 7. Negative, 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 there's a negative. 3 times 3 times 3, so we can cube root negative 27. So it's these square roots that are going to cause problems, and we need to put restrictions on. So if we take a look at page 7, I know we skipped something, but we're going to come back to it. But right now, page 7, restrictions on variables. I want to try to figure out if I want to square root 4a. Well, the question is, can a be anything? If I said that a was equal to 2, well, square root 4 times 2 would be the square root of 8. Now, it's not a perfect square, but can we square root 8? Yes, we can square root 8. So a equal to 2 is fine. What if a equaled 200? Well, if a equaled 200, 4 times 200 would be the square root of 800. Can we square root 800? Yes, absolutely. Again, not a perfect square, but it's still going to give us a value. What if a equaled negative 2, though? If a equaled negative 2, we would have 4 times negative 2, which would be the square root of negative 8. Can we square root negative 8? We cannot. It's not allowed. So a equal to negative 2 can't happen. And that's what we have to figure out. What a values aren't going to be allowed? Well, if we take a look at this, square root of 4a, we can't have the 4a, the radicand, has to be a positive or 0. We need to have a value under the root sign that's 0, because the square root of 0 is 0. That's allowed. And the square root of a positive is allowed. We can't have a negative value under there. Well, what's going to make 4a a negative? What's going to make 4a negative? If a is negative, that's going to create 4a negative. So a can't be negative. So we would write the restriction in this case. A must be greater than or equal to 0. If a is 0, 4a, if a was 0, would be 4 times 0, which is 0. That'll work. If a is greater than 0 or positive, any positive value, 4 times something positive, will be positive, and that's okay. So the restriction in this case is that a must be greater than or equal to 0. And that, now this is a whole big long ramble, but this is what we want to get to and understand. The 4a has to be positive, which means a has to be positive. So if we took a look at another one, cube root of 7y. Well, because it's a cube root, we could have a positive or negative radicand. They're both okay in this case. Well, if we could have a positive or a negative, what could our y be? Well, y could be anything because a positive y is okay. But in this case, a negative y is also okay because we showed you just a minute and a half ago that a cube root of a negative is fine. So are there any values in this case that won't work for y? There aren't. So in this case, y is a member of the reals. Y can be absolutely anything. There's no restrictions because we can cube root positives or negatives, so y can be anything. There's your restriction, identifying what y could be. So here's 3 more. Give them a try and then come back to the video. So here we go. Square root of x. What do we know about a square root? The radicand has to be positive. So what do we know about or 0? Sorry. Has to be positive or 0. So in this case, x must be greater than or equal to 0. There's the restriction. If x isn't greater than or equal to 0, it's not possible to do. Cube root of m, just talked about it. Cube root means m can be either positive or negative. So m is a member of the reals. M can be absolutely anything. Now a 4th root. 4th root's interesting. Oh, just a second. Here, we need the 4th root. So I need to figure out what times itself 4 times, because it's a 4th root. What if I multiply anything 4 times? If I multiply 4 negatives, it's going to be a positive. So again, a 4th root means 7y needs to be positive or 0 only. So y has to be greater than or equal to 0. It can't be a negative because there's no way that something times itself 4 times will give a negative. So y has to be a positive. I can't have a negative value underneath here because 4 negatives when they multiply is a positive, so this has to be a positive value. Here we go with the last 2. Now, there's more here. We have to think a little bit. Again, this, because it's a cube root, can be positive or negative. The index is really the key with this. Because we need positive or negative, X can be absolutely anything. Y can be absolutely anything because we're okay with positive or negative. So any X or Y value will work. And the last one with the square root, 121 m cubed n squared. Because it's a square root, this must be positive or 0. So if it's positive or 0, how do I create a positive or 0 value? Well, this one is a little tricky. Let's deal with the m cubed first. What m value? I need this to be positive, and because it's exponent 3, m must be greater than or equal to 0. Because if I put a negative m, I'm going to have negative times negative times negative, which is a negative. I don't want a negative under the root sign. So my m has to be positive or 0, because if m is negative, well, that's going to make this whole thing negative. So there's the first one. But n, we see that n is squared. So because it's squared, if I put a positive for n, if n equaled 1, a positive, well, positive times a positive is still a positive. So that's not a problem. But if n were negative 1, that's actually okay as well, because we're squaring n. Any negative value squared will be a positive. So this n situation here could be anything, because squaring a negative will make it positive, and a positive under here is okay. So there's the restrictions for that situation. Kind of tricky. You gotta just do some practice. So page 278, 1 to 4 is more questions about the mixed and entire radicals, but it also asks for restrictions. Few questions, give them a try, and consider and check the restrictions in the answer section. Something to think about. What answers will make sense? Think about it. Have fun.